Dear students, welcome for the last session or the fourth session with respect to numericals from the chapter, that is solutions. So nearly 18 numericals that I have solved with respect to the colligative properties and then the application of the Rolle's law of liquid mixtures. Okay, so let's have the solving with respect to the 19th. What's that? Benzene and toluene form an ideal solution obeying the Rolle's law. The vapor pressure of the pure benzene at 88 degrees Celsius is found to be 957 millimeter of mercury, and that of a toluene at the same temperature is found to be 380 millimeter. Calculate the composition of benzene and toluene. Again, we are having the two liquids called as benzene and toluene. Let first make it very clear. AB benzene. AB benzene, having a formula, what is that? C6H6 and BB toluene. Toluene formula is actually C6H5CH3. Methyl benzene is also called as which one? Toluene. Okay. The vapor pressures of the pure benzene and that of toluene. Vapor pressures of pure benzene means PA naught is equal to how much it is? 957 in terms of millimeter of mercury, and PB naught is equal to, B here is not benzene, it is toluene here. It is going to be the 380 in terms of same mm of mercury. Calculate the composition of the mixture. Composition means either I can find the number of moles or it may be the mole fraction, whatever it may be. Here, XA we have to find out and XB also we have to find out. X and XB. So here, as it forms an ideal solution, assume P total is found to be 760, standard pressure, that is equal to 760. By Rolle's law, what's that? Rolle's law. P total is equal to PB naught plus PA naught minus PB naught into XA. So when I am discussing with respect to the Rolle's law of liquid mixtures, I have given the four different set of formulas directly. So we know that first, I'll just have this. We know that PT is equal to PA naught into XA plus PB naught into XB. Okay, what is this? It's indirectly the application of which one? Rolle's law of liquid mixtures. So here, this is also mentioned as PA naught into XA plus PB naught into, can I write this as 1 minus XA here? Because the sum of the mole fractions is always equal to what? 1. Therefore, instead of XB, just I mentioned that as what? 1 minus XA, that is equal to PA naught into XA plus PB naught minus PB naught into which one? XA. So first I will write the PB naught plus, among these two XA is common, therefore it is PA naught minus PB naught into XA. Means directly what I written? P total is equal to PB naught plus PA naught minus PB naught into what? XA. Okay. Based on that I will calculate the value of which one? R. What is XA is equal to here? PT minus PB naught. PT minus PB naught divided by PA naught minus PB naught. I have written the direct step first. Okay. Means first PT minus PB naught is equal to PA naught minus PB naught into XA. Therefore, what is XA? PT minus PB naught divided by PA naught minus PB naught. That is equal to, what is PT here? 760 minus 380 divided by, what is PA naught minus this one is 957 minus 380, 380. Okay. So I think directly I will write the answer R in the form of the value of XA is calculated as 0.66. 0.66. What is that? 0.66. It is a mole fraction of A. What is A here? It is the benzene. Therefore, what is XB is equal to 1 minus XA directly. 1 minus 0.66, that is equal to 0.34. What is 0.34? It is the mole fraction of B. What is B here? It is not the benzene, it is the toluene. Means indirectly we are calculated the mole fraction, means it is the number of moles. Number of moles means it is the amount of the substance. Therefore it is called as which one? Composition. Composition means just we have to find out the value of either the mass I can calculate, or it may be the number of moles I can calculate, or I can directly use the value of which one? The mole fraction. By knowing the mole fraction I can calculate the number of moles, but there is no need of that. By knowing the number of moles I can calculate the respective mass. Okay, so this is how we are going to solve this numerical, which is the application related to the Rolle's law of which mixture? Liquid mixtures. Okay, so that is the numerical number. How much? It is the 19th. Okay, let's have the 20th. The vapor pressures of the pure liquids A and B are respectively what and what? 450 and 700 millimeter of mercury at certain temperature of 350. Find out the composition of the liquid mixture if the total vapor pressure is found to be the 600 millimeter. Composition means again we have to find out the mole fraction. Okay. If the total vapor pressure is found to be the 600 millimeter of mercury. Also find that there is another one. Composition in the or of the vapor phase. First you have to calculate that the total vapor pressure or the composition of the liquid mixtures. Then you have to find out the same composition with respect to the vapor phase. Means we have to have the double calculations here. Okay, so let us solve now. Here there is no names with respect to solute and then the solvent are the two different liquids that are left. They have mentioned in the form of only the capital A and capital D. Okay. So here the two liquids are what and what? A and B. Directly their vapor pressures are given as what and what? PA naught is equal to I think 450 mm and PB naught is equal to how much? PB naught is 700 in terms of millimeter of mercury. Find out the composition of the mixture if the P total is how much? What is P total given? It is going to be the, how much it is? 600 millimeter. 600 millimeter of mercury. First you have to calculate the value of XA and then the XB. First we have to calculate that. Okay. Same I think it is application with respect to the which one? The Rolle's law. We know that. What's the formula? Directly I will write that previous formula. P total is equal to PB naught plus PA naught minus PB naught into XA. Or directly, previously what I have done, the same formula. XA is equal to PT minus PB naught divided by PA naught minus PB naught. PA naught minus PB naught. That is equal to. What is PD here? 600 I think. 600 minus PB naught is 700 divided by what is PA naught? 450 minus 700. That is equal to minus 100 divided by minus 250 means it is 2 by 5 I think. 2 by 5 means it is 0.4. What is 0.4? It is XA. What is 0.4? It is, I think I will get the value as X is equal to what? 0. Yes, the mole fraction of A is going to be the 0.4. Therefore, what is XB here? 1 minus XA, that is equal to 1 minus 0.4, that is equal to 0.6. What is 0.6 here? It is 0 XB. What is XB here? It is a mole fraction. Also, we have to calculate the what? Vapor pressure, the composition of the same in the vapor phase. In vapor phase, number of moles is always proportional to respective partial pressures. That you have to remember first. Because as if we have calculated the composition of the liquid mixture, but now you have to find out the composition of the same in the vapor phase right now. So here this vapor phase depends upon the partial pressure, number of moles of that particular liquid directly proportional to which one? The partial pressure. So therefore we can calculate the value of partial pressure such that it is nothing but the what? Number of moles. Therefore by RL, what is RL? Raoult's law. What is that law? Raoult's law. PA is equal to PA naught into XA, that is equal to what is PA naught? 450 into what is XA? XA is 0.4. What is that on simplification? 45 fours are 45 fours are 45 fours are, it becomes around 180, I think 180 millimeter of mercury. Similarly, what is PB here? PB naught into XA, sorry XB. What is PB naught? 700 into how much it is? 0.6. 7 6 42. 42 means 420 in terms of millimeter of mercury. Therefore, Na proportional to Pa, Nb proportional to Pb. Let Ya and Yb, Ya and Yb be the mole fractions of which and which? A and B in the which phases here? Vapor phases. The what phases? Vapor phases. Therefore, Ya is equal to Na divided by what? Ya is equal to Na divided by Na plus Nb. Ya is equal to Na divided by Na plus Nb. But there is no Na and Nb here. But how N is? It is directly proportional to this. Therefore, it is equal to PA divided by PA plus PB. PA divided by PA plus PB. What is PA here? 180. Divided by addition of these two, I think it is 600. Directly I will write that as. So it is, I think, 3 by 10. 3 by 10 means it is 0.3. What is 0.3? It is the mole fraction or the composition of A in the what phases? Vapor phases. Similarly, what is YB? It is 1 minus x y A, that is equal to 1 minus 0.3, that is equal to 0.7. What is YB here? It is the mole fraction of the composition of the liquid B in the what phases? Vapor phases. So there we are having the original XA and XB. What are these? They are the composition or the mole fractions of the two liquids called as A and B in the what mixtures? Liquid mixtures. After that we have calculated the value of the same mole fractions of the composition with respect to the vapor phase. For vapor phase or in vapor phase, how these two are? Number of moles always proportional to the respective what pressures? Partial pressures. Means as if we didn't have any mass. Instead of that, the number of moles is calculated with respect to the partial pressure, that is N proportional to P. Therefore, Na proportional to Pa and Nb proportional to Pb. Means instead of calculating the value of Na and Nb, I have calculated the value of which and which? Pa and Pb. How Pa and Pb are calculated? By the application of what law here? Raoult's law. That is Pa is equal to Pa naught into Xa and Pb is equal to Pb naught into Xb. On simplification, I am getting the values as 180 and then 420. Then apply the same. Let Ya and Yb be the mole fractions of the two liquids called as A and B in the what? Vapor phase. Therefore, Ya is equal to Na divided by Na plus Nb, but we didn't have the value of which one? Na and Nb here. But N proportional to P means Na must be proportional to Pa and Nb must be proportional to Pb. So upon simplification, I am getting the value of Ya is equal to 0.3, therefore Yb is equal to 0.7. Okay. So this is about the application of the liquid solutions with respect to the vapor phase. If vapor phase is as just we have to proportional. What is that proportional? Number of moles of that particular liquid is always proportional to the respective what pressures? Partial vapor pressures. Okay. So that is about the numerical number, how much it is the 20th. Next we will have the 21st. So now we will move on to the numerical number 21st. What's that? The mole fraction of helium in a saturated solution at a certain temperature is found to be 1.2 into 10 to the power of minus 6. Helium is a gas. Helium is a gas. Therefore, this is an application of, or it is a type of solution that is called as gas liquid solution. If gas liquid solution is the case, means it is indirectly the application of what law here? The Henry's law. What is the Henry's law here? Partial vapor pressure that has been exerted above the surface of the solution is directly proportional to the what fraction? Mole fraction of the gas that has been present inside the solution. P proportional to X, or P is equal to KH into X. Here KH is called as what? Henry's law constant. Henry's law constant. So here the mole fraction is given. What is that? X is equal to how much? 1.2 into 10 to the power of minus 6. Okay. Next is determine the pressure of helium above the solution. It is not the original pressure. Pressure of helium above the solution means it is indirectly the partial pressure of helium. Means X helium, partial pressure of helium. And also the KH with respect to helium is given as, what the Henry's law constant with respect to helium at that temperature is 1.5 into 10 to the power of 5 in terms of which one? Atmosphere. Direct solution. By what law? Henry's law. By what law? Henry's law. P is equal to KH into XR. What I need actually? Directly P itself. Pressure of helium, Henry's law constant. What is the Henry's law constant here? 1.5 10 to the power of 5. Into what is the mole fraction of helium? 1.2 into 10 to the power of minus 6. Upon simplification, I will get the value as 0.18. As it is in atmosphere, means the pressure is also in atmosphere. Mole fraction doesn't have any unit. The pressure is having a unit of atmosphere, means it is having the same unit with respect to the Henry's constant, that is equal to ATM. Okay, the Henry's law constant is having the same unit as that of the pressure unit. Okay, so that is a application with respect to which one? The Henry's law. So let's move on to the 22nd, I think. Hydrogen sulfide is a which gas? A toxic gas, which is having a smell of a rotten smell, rotten egg, is used for the qualitative analysis. Hydrogen sulfide. If the solubility of hydrogen sulfide in water at STP is found to be 0.195 molal, then calculate the what constant? Henry's law constant. So here the gas is hydrogen sulfide. I think it is dissolved in, or it is treated with a solvent like water at a condition of STP. Then calculate the what constant here? Henry's law constant. If the solubility, yes, is equal to how much it is? Molar. Small m means it is called as molar. What's the meaning of that? 0.195 molal means how many moles? 0.195 mole of solute, which is solute here, H2S, in 1 kg or 1000 grams of solvent that is called as water. That's the thing, that's all. Okay? How many moles here? 0.194 moles of a solute. Which is a solute here? It is a hydrogen sulfide, and then it is dissolved in how many grams of solvent? It is 1000 grams of solvent. Therefore, N of H2S is 0.195, W of H2O is given as 1000 grams. Therefore, how to calculate number of moles of this one? It is number of moles of water It is W of water divided by molecular mass of water. That's equal to. What's the mass of water here? It is 1000 divided by 18. 18 is the molecular mass of which one? Water. That is equal to 55.55 moles. Number of moles of this and this are given. Therefore, what is X of H2S? Mole fraction of H2S. Mole fraction of H2S is equal to number of moles of H2S divided by number of moles of H2S plus number of moles of H2. That is equal to H2S is 0.195 divided by 0.195 plus 0.55.55. So if I simplify that, the mole fraction of H2S is found to be 0035. 0035. What is this? It is a mole fraction of which one? H2S. We have to find out the KH for H2S. Here, STP means pressure with respect to hydrogen sulfide is found to be 1 atmosphere. 1 atmosphere. Okay? Just by saying what lie here? Henry's law. What lie here? Henry's law. P is equal to KH into XR. What I need actually? Calculate the Henry's law constant. Therefore, KH for H2S is equal to partial pressure of hydrogen sulfide divided by mole fraction of hydrogen sulfide. That's all. What's the partial pressure is nothing but it is 1 atm divided by, what's the mole fraction of that? It is 0.0035. 0035. So simplification of that gives Henry's law constant with respect to that is given as 22nd, 1 divided by 0.0035, it is 285.7. 285.7 in terms of atmospheres. So that is the difference here. But the thing is, there the Henry's law constant and then the mole fractions are given. That is why we have calculated the partial vapor pressure of helium in the previous problem. But here, partial pressure is given in the form of STP. Therefore, the partial pressure of H2S is 1 atm, and then he has not given the, which one? The mole fraction, but he has indirectly given that in the form of solubility. What is the solubility here? 0.195 in terms of molal. What is the meaning of molal means? 0.195 mole of the solute called as H2S is dissolved in which one? 1 kg of solvent. Which is the solvent here? It is the water. Means number of moles of H2S is 0.195 and the mass of that water is found to be the 1000 grams. Then how to calculate number of moles here? Mass of water divided by molecular mass, that is equal to 55.55. Then find the value of mole fraction of gas. What is the gas here? H2S. It is equal to number of moles of that gas divided by total number of moles. On simplification, I will get the value as 0.0035. Then Henry's law constant is equal to, that we have to find out. Same by the application of what lie here. Henry's law, P is equal to KH into X, or KH of H2S is equal to partial pressure of hydrogen sulfide divided by mole fraction of which one? Hydrogen sulfide. So on simplification, I will get that as 285.7 in terms of atmospheres. Okay. So that is a numerical number. How much? 22. Let's have the 23 here. Henry's law constant for carbon dioxide in water means gas is carbon dioxide and the liquid solvent is found to be the water. It is given. Henry's law constant is given. Calculate the quantity of carbon dioxide in 500 ml of soda water. 500 ml of which water? Soda water. When packed under a pressure of 2.5 atm carbon dioxide at 298 Kelvin. What is KH given? 1.67 10 to the power of 8 in terms of pascals. Calculate the quantity. Quantity means either the number of moles or I can have the mole fraction also. Quantity means number of moles of which one? Carbon dioxide. That you have to find out. Number of moles. 500 ml of soda water, volume of soda water is given as under a pressure means the partial pressure of which one? What is that gas here? It is CO2. It is equal to 2.5 atm. that is equal to 2.5 into 101,325. Why? Because this Henry's law constant is expressed in a pressure unit of pascals, but here it is in ATM. Therefore, convert ATM into what? Pressures, pascals. How? By multiplying it with 101 point, this one. Because 1 ATM is 101,325 in terms of pascals. 1 ATM is how much? 101.3 or 101,325 in terms of pascals. That is equal to, on simplification, I will get the value as 253312. 253312.5 I think. 5 in terms of pascals. Because kh is expressed in pascals means this is also expressed in pascals. Then, how to calculate the mole fraction here? Mole fraction is equal to what by what? By what law? Henry's law. Henry's law. What's the Henry's law here? P is equal to kh into x. I need the x value first. X is equal to P by kh. This is for CO2. This is also for CO2. So here it is, I think 253312.5 divided by, what is the kh value given? 1.67 into 10 to the power of 8. That is equal to. So we will have the simplification with respect to that. It is 1.52 into 10 to the power of minus 3. What is this? Mole fraction. What is mole fraction here? Number of moles of carbon dioxide divided by number of moles of carbon dioxide plus number of moles of water. That is equal to 1.52 into 10 to the power of minus 3 divided by, let's have that. Okay. So here 500 ml of soda water means 500 ml of water itself, because it contains water, which is equal to 500 grams of water. Why? Because density for water is 1. Only for water the density is 1. That is equal to 500 divided by 18, that is equal to 27.77 moles of water. Means, what is the meaning of 500 ml of water? Means it is number of moles of water is given as how much? It is 27.77 or 78 I think, something. 27.77 or 78, okay. That is 1.52 plus into 10 to the power of minus 3 plus number of moles of water is equal to how much? 27.77. So that is nearly equal to number of moles of carbon dioxide. Okay, number of moles of carbon dioxide, that we have to find out first. Number of moles of carbon dioxide. Number of moles of carbon dioxide. Number of moles of carbon dioxide plus number of moles of water. Number of moles of water is that. Okay. But this value is very, very small. N of carbon dioxide divided by 27.77 is equal to, and what is the value of that here? 1.52 into 10 to the power of minus 3. Why? Because number of moles of solute or the gas is negligible as compared to that of 27.77 moles of which one? Water. Therefore, number of moles of carbon dioxide is equal to 27.77 into 1.52 into 10 to the power of minus 3. That is equal to how many moles on simplification? That is equal to 0.0422. 0. In terms of moles. Number of moles. Suppose if they ask the mass of that. Suppose if they ask the mass of that. Mass of carbon dioxide is equal to number of moles of carbon dioxide into molecular mass of carbon dioxide. Number of moles is 0.0422 into molecular mass of carbon dioxide, I think it is 44 grams. That is equal to. So I will directly write the final answer 1.86 in terms of grams. I think here itself we can stop because it is quantity may be either in the form of mole fraction or the number of moles, or it may be the mass. But how to calculate number of moles from mole fraction? It is the number of moles of that substance divided by total number of moles. But how we are getting the total number of moles? As it is 50 ml of soda water means we are having 500 ml of soda water means we are having 500 ml of water. What's the meaning of 500 ml of water? Also called as 500 grams, because the density for water is nearly 1. If density is 1 means mass is always equal to its volume, means 500 ml means it is 500 grams. If it is 500 grams means it is divided by 18 in terms of number of moles, and the number of moles of water is equal to 27.77 or 78 in terms of moles. Then substitute here, but number of moles of carbon dioxide is very less as compared to that of the total number of moles of which one? The solvent called as water. Therefore, I am neglecting number of moles of carbon dioxide. Therefore, N of carbon dioxide divided by 27.77 is equal to the mole fraction is calculated as how much? 1.52 into 10 to the power of -3. On simplification, the number of moles of carbon dioxide is found to be the 0.0422 in terms of moles. But if I want to have the mass of carbon dioxide, how to calculate mass from moles into respective which mass? Molecular mass. So this is about the calculation of quantity either in the form of mole fraction or the number of moles, or it may be the mass of carbon dioxide. Okay. So let's move on to the last numerical related to the same solution chapter. Let's move on to the last numerical for the solution chapter. Again, it is indirectly the same application with respect to the Henry's law. If nitrogen gas is bubbled through water, decided here. Gas, liquid. Gas is nitrogen and so liquid is water. Okay, solute is nitrogen and solvent is water. How many millimoles of nitrogen gas would dissolve in 1 liter of water? 1 liter of which one? Water. Assume that the nitrogen exerts a partial pressure of 0.987 in terms of bar. Given the Henry's law constant for nitrogen is found to be the 76.48 in terms of kilobars. Number of moles of nitrogen we have to find out first. First we have to get the moles and then we will calculate that in the form of millimoles. It exerts a partial pressure. What is the partial pressure of nitrogen given? It is 0.987 in terms of bar. Then the Henry's law constant Kh for nitrogen is equal to how much it is? 76.48 kilobars. 76480 in terms of bar, because that is bar, here it is kilobar, therefore just multiplied by 1000. Okay, so direct, I think first you have to calculate the mole fraction. From the mole fraction then I will calculate this one. Okay, so here first one thing, 1 liter of water means 1000 grams of 1000 cm cube, which is equal to 1000 grams of H2, which is equal to 1000 divided by 18, that is equal to 55.55 moles of water. That is N of H2O is equal to 55.55. You have to remember directly also, if you want to have the solvation in the numericals. 1 liter of water itself is what? 55.55. So in the previous problem I have mentioned the 500 ml of soda water. 500 ml of water, soda water means how many moles we are having? 27.77 or 78 we are mentioning. What is the double of that? It is 55. Means 1 liter of water means it is always 1000 ml. 1000 ml means 1000 grams. Why 1000 ml is equal to 1000 grams? Because already I have mentioned the density for water is equal to how much? 1. If it is 1000 grams means how many moles are there? 1000 divided by respective molecular mass. What is the respective molecular mass? It is 18. Therefore, it is equal to 55.55 moles. Means you remember directly, if it is 1 liter of water means it is equal to how many moles? 55.55 in terms of moles. Okay. So that is number of moles of water is given. By what law again? Henry's law. P is equal to, we know that it is Kh R. What is X is equal to? P divided by Kh. It is for nitrogen, this is for nitrogen, this is for nitrogen. Okay. What is partial pressure of nitrogen? The pressure with respect to nitrogen is 0.987 in terms of bar divided by what is kH for nitrogen? 76480. 76480. That is equal to, what happens when I simplify that? 1.29 into 10 to the power of minus 5. 1.29 into 10 to the power of minus 5. What is this? Mole fraction. It is mole fraction is given, but we have to calculate that in the form of which one? Number of moles. So here, n of n2 divided by n of n2 plus n of h2, which is nearly equal to n of n2 divided by n of h2o. Why? Because number of moles of the gas is very less as compared to that of the number of moles of the solvent. Means we are neglecting n of n2 compared to these two. And that is equal to 1.29 into 10 to the power of minus 5. Because if you want that, number of moles of nitrogen plus number of moles of water is nearly equal to number of moles of H2. Because with respect to the dilute solution of the gas in the liquid, we are always neglecting the amount of the gaseous solute as compared to that of the total higher volume or the number of moles with respect to solvent. Is the solvent here? It is the water. Okay. So therefore, number of moles of nitrogen is equal to number of moles of water into 1.29 into 10 to the power of minus 5. That is equal to, number of moles of water is how much? It is 55.55 into 1.29 into 10 to the power of minus 5. That is equal to, so if I simplify that, I will get that as minus 3 or minus 5 here. It is minus 5. 7.76, 71.6 into 10 to the power of minus 5 in terms of moles. How to convert moles to millimoles? How to convert moles to millimoles? That is equal to 71.6 into 10 to the power of minus 5 into 10 to the power of 3 millimoles. That is equal to 71.6 into 10 to the power of minus 2, that is equal to 0.716 millimoles. Why? Because 1 moles is equal to how many millimoles? 1000 millimoles. 1000 means 10 to the power of 3. Therefore, it is 10 to the power of minus 5 into 10 to the power of 3, it is 10 to the power of minus 2. On further simplification, I will get 0. Either it is correct or not, 0.716 in terms of which one? Millimoles. This is the final answer. Okay. So here, to be very clear, if the total number of moles of the solute and then the solvent is considered, we are usually neglecting the number of moles of the gaseous solute as compared to that of number of moles of the liquid solvent. Here, number of moles with respect to the water or the solvent is going to be the 55.55. It is very high as compared to that of 0.716 or 71.6 into 10 to the power of minus 2 moles. That is why we are always neglecting the number of moles of the gaseous solute as compared to that of the total number of moles with respect to the solvent, liquid solvent. Okay. So I think this totally completes the whole of the theoretical concept along with the numerical problems with respect to the physical chapter that is called as solutions. Okay. So in the next class we will have the discussion with respect to the competitive, that is the solving of multiple choice questions for the same chapter that is called as solutions. Okay. So that we will do or conduct that in the next upcoming sessions for the competitive with respect to either CET or NEET or it may be the JMEINS. Okay. So thank you very much.